But we want to look at the dimensions that we defined. This was head length and breadth, but let's look at the relationship between head length and the dimension that we just computed, that fore-aft distance from ear to nose. And we'll do that versus head length. And what you see is, well, there's some correlation there. Not particularly strong, but there's a fair amount of correlation. That's not a surprise. But it does point out that there is variance that in that dimension that's not perfectly related with the overall head length. We can also look at that other dimension that we created, nose width. You see essentially uncorrelated with nose width. The nose doesn't have much to do with that. Let's look at whether the nose width is related to the head breadth of the ear. Well, a little bit of correlation, maybe not as much as you might expect, and certainly not as much as you get if you use a predefined set of head forms that were based on other dimensions. As we select these dimensions, you can see they appear here in this table, and we can pop this table out. We can download this for analysis elsewhere. I can select a subject here, and it appears in that data set. For example, I can sort this. There's our shortest ear to nose distance in this population. You see that's a certain shape of head, and here's our longest, quite a large head. We can do this on all of the other dimensions as well. Anything that we can define, we can sort on that, and we can download it for analysis. This is where the statistical capability gets pretty powerful. So very often we want to understand the relationship between variables. And more generally, how does the shape, for example, of the rest of the face or the area around the eyes, how does that change with this distance here? Let's just define another landmark just to have a little more to work with. I'll just put a symmetrical point here and get another dimension. We'll just call it that. And now we can create a regression that'll allow us to generate heads based on the particular values or particular dimensions we care about. So let's take that head breadth and our nose width, say, and also fore-aft ear to nose. Let's take all three of those. Now we've got a regression that allows us to manipulate those dimensions directly, and we can reference the percentiles of that. So for example, our head breadth at the ear looks like a big value, 160 some. And we can see that effect on the whole head. What you're seeing is all of the effects on the whole shape that are associated with this. So for example, if you're making a design and you have a large size, say, how should the rest of it be designed? What pandoscopic tilt should you use? What's the shape of the nose across that population? It can be wide, can be quite narrow. And of course, there are many other nose dimensions that you could potentially consider. And here's that fore-aft distance, the length of the temples. So if you have a particular, for example, common use of this would be to take a particular size of your product and ask what the average head size that matches that product is. Generate a head form, for example, that goes with that size product. And this gives you that in a statistically robust way. Turning to the Shapes tab, the Shapes allows you to do a few things. The simplest is to simply take the shape that you have here and save it for future use, potentially comparing with another um, sharing, potentially comparing with another shape. So let's just do that. Let's go back to our predictors. Let's make a big head and we'll save that. Just name it so I know which one it is. And go back to our predictors and let's make a small head. We'll make it female. And again, we could be using fifth percentile values. We could be using any values we care to use here. We'll go and we'll save that shape. And now let's look at those together. So first I'm going to hide the main model. And now I can unhide, but I'll make it transparent, those two heads. So you get a very good qualitative sense of the range of head sizes in the population. Of course, these can be set based on linear dimensions, based on curved dimensions, circumferences, whatever you care to use. And this is one way to generate head forms that you can use in CAD, for example, by downloading these heads. You can see right here, I can download in STL, OBJ, apply format.